part C of our note sheet of that worksheet, which is about roses. Before we get to filling out those notes, we're going to just do a little bit of exploration. We're going to play around with some different functions. We're talking about a polar graph, which is called a rose today, and it has to do with the fact that most of the graphs look like flowers of some sort. What we have right here in front of us is this function f of theta equals 6 cosine theta. This is a polar equation where f of theta is equal to my radius r, so we could write this as r equals 6 cosine theta if we wanted. We talked about it really briefly in class, this is actually what we would call a one-petal rose, but it's also a circle. And so we're going to look at this. We're going to look at some other roses with different numbers of petals. But before we do that, I just want to look at this circle here and say, okay, what about the function? What pieces of the function tell me about this circle, about this one petal rose? Okay, so the first thing I want to look at is the coefficient in front. And I want to see what happens if we change that coefficient. How does that change my function? How does that change my graph, my rose here? So we're going to start with this first one here, this 6. All right, that's 6 cosine theta. If you look about this one petal rose, you notice that the distance across that petal, or distance across the circle, is a length of 6. So let's see if that holds. If I made this 9, notice how when I change my coefficient to 9, that now changes the distance across my petal to also be 9. And we can just check one more and make sure it actually works. If I made this 4, now the distance across my petal is 4. So I have this connection between the coefficient in front of my sine or cosine is connected to my petal length. What happens if I negate it? If I put a negative, now it's going to have a length of -4. And we talked about it when we introduced polar last time, that when you have that negative radius, how that goes in the opposite direction of our angle. So if we think through this first one, my petal is going off towards that 0-degree angle. So if I'm going to go in the opposite direction, this should, if this theory works out, go towards the 180-degree angle, or straight off to the left, which it does. And so if I were to negate it but change it so it's now -6, we now have a -6 petal length. All right, so that first value, that changes our petal length, how long our petals are. And we're going to look at ones that have more petals in just a minute. But we can see how long our petal is. The next thing that can change is our function. So roses are going to be either sines or cosines. So we can see that, no matter what I change this to, if I made this, +9, oops, not 96, that's way too big, like +9, or we did +5, or we did -5, all of these different things, we're still sort of stuck either in that 0-degree direction or that 180-degree direction. We're kind of stuck on that horizontal axis. If I were to change my function, so instead of cosine, we're now at sine, you can make an educated guess that instead of being stuck on that horizontal axis, we're now going to be on that vertical. So negative is going to be going down towards that 270-degree angle, or the 3π/2 radian. Whereas if I made this +5, we should be going in the 90-degree direction, or the π/2 radian direction. But we're stuck on that axis. So you think back to, cosine is always connected to our x, that horizontal value. Sine is connected to our y, that vertical value. That plays a part here. All right. So far we've seen the coefficient in front tells me petal length, the direction of that petal length. The function tells me sort of where am I stuck? Am I stuck on the horizontal, or am I stuck on the vertical? And that's going to change a little bit when we get to petals. But what I want to do is I want to change my number of petals, because if I'm stuck with just one petal, then there's really nothing special about it. It's just a circle. But I can change the number of petals. I can add more petals to it. And how I change the number of petals is with that input. So right now for sine, I have 1 theta. And I'm actually going to end up I'm going to go back to cosine right now. Oops. I don't want to do cosine of sine. If I go back to cosine, we're stuck on that horizontal. But what I want to do is I want to adjust my input. I'm going to change it to be 3. So when we had 1 theta, well, we had 1 petal. We have 3 theta. Now we have 3 petals. This is a 3-petal rose. And you can see how this rose on the right goes off to that 0-degree angle. So that furthest point on the petal on the right is at 0 degrees. It's 5, 0. If I do, say, 5 theta, now I have 5 petals, and you can see that that first petal, still the furthest point on that first petal, is still at 0 degrees for theta. So it's 5 for R, 0 for theta. So this is a 5, 0 point. 5 radius, 0 theta. But you can see how if I, change this input, I change the number of petals. So 3 thetas, 3 petals. 5 thetas, 5 petals. 7 theta, 7 petals. What if I tried 4? Okay, you can just say it out loud or think it to yourself. How many petals do you think 4 would have? If you said 4, that is a good guess, but you're actually wrong. 4 theta produces 8 petals. 8 petals. All right. 6 theta produces 12 petals. 8 theta produces 16 petals. 2 theta is going to produce 4 petals. So how many petals my rose has, that depends on the coefficient in front of theta, but it's not just going to match that value, right? And we're going to write this down and we're going to get all these details on the notes in just a minute. But that coefficient in front of theta, that's going to affect my petal number, but it's not always going to match. If the coefficient is odd, then it's going to be exactly that many petals. But if my coefficient is even, I have to double, which puts a little trick to some things. I can't have a 6-petal rose. I can't. Because if I put in 6 theta, we get 12 petals back. So I think, okay, well, I have to do half of that. So I do 3 theta. But if I do 3 theta, I get a 3-petal rose. So 6 petals is not possible. I can have any odd number of petals that I want. And then I can have any even number of petals as long as that number is divisible by 4. So I could have 4 petals, 8 petals, 12 petals, 16 petals, so on. But I can't have 6 petals. I can't have 10 petals or 14 petals or anything like that. All right, so far with all these extra petals, we've looked at we've looked at cosine. We're going to look at sine, see how that changes things a little bit. If I look at sine before with that 1-petal rose, we said that was stuck sort of with that vertical axis, and that kind of applies, though not quite. Notice how this one, we go to, sine with 3 theta, and you can see how it is sort of stuck with that vertical axis. But now my coefficient, remember, that's a +5, so we would expect it to go +5 up here, but really it starts down there. So it's a little bit trickier with sine. We're going to talk through how we can, figure out where my first petal starts, where that, first point starts in just a little bit. It's not quite so straightforward, but we can look at this. If I, let's do 4 theta, so we get 8 petals. You can see how, it's symmetrical with the y-axis. It's also symmetrical with that horizontal axis, but you can see it's symmetrical with the vertical axis, but it doesn't go along it, sort of like we saw with always happening with the cosine. So whether it's cosine or sine, how we start drawing is going to be a little bit different. We're going to talk about all of that. I just want to show a couple other graphs. So we've got this green graph in here, which is this one right here, which is -3 sine 12 theta. So we should have double 12, 24 petals. I'm going to go back here and I'm going to change this back to a cosine. Oops, not change a new value. I want to change my function. Cosine, throw that in there. And what we're going to do is we're just going to have a fun little, we're going to zoom in and out. So you see we've got a 8 petal and a 24 petal, and just how these flowers look and grow. And you can do anything. You can make these beautiful pictures out of these polar graphs, these roses. And the reason why they're called roses is because with these more petals, you create these flower-like graphs. But you can have the 1 petal rose, which is just a circle, or you could have the 2, or you can't have 2, but you could have the 3 petal, or the 4 petal, or the 5 petal. What we're going to do right now is we're going to go move to the note page in that worksheet. So you want to go ahead, grab that out. We're going to go to part C, which is on the 4th page down at the bottom. So we're going to move to there right now.